Okay, let's see. Eeny, meeny, miny, mo. Let's start with Rodrigo, Torch Deploy, and Pybind 11 upgrade. So the way I'll structure this one is Rodrigo, briefly tell us about what your problem is, and then Albin, tell us about the Pybind 11 upgrade, and then we'll open the floor for discussion.
All right, so the issue I'm seeing is that I'm trying to define a set of ops all in Python, and it essentially doesn't work at all with Torch Deploy. No matter how much I try, it just doesn't. It fails. I'm trying to copy the implementation from other other parts of PyTorch that are doing the same, like Prems, and it fails. It fails consistently because it is just trying to double register. To be honest, it's really strange because the more I look at the code, the more it makes sense that it should work to begin with. Yeah, I don't know. I'm stuck there. It doesn't seem to. I don't think I have a exact path out of it because I can't get multiply, like Torch Deploy to work locally. And so right now I'm just like randomly throwing changes at CI to see if anything shows up, what's happening there. But it doesn't seem to be even possible to do what I'm trying to do, which I don't quite understand how prims work at all. Like the current code doesn't allow you to define a library, only to add implementations to it. It will definitely fail if you try to do it twice. So.
Okay, quick poll. Does anyone here in this meeting know how to do a local build of Torch Deploy multipy? Just shout out if you are.
Yes.
Oh, Alvin, you do? Because I don't. I tried. Last time I had to deal with a Torch Deploy problem.
Well, I had to recompile a C Python from source with very specific flags to get it to run.
Okay, thanks Rodrigo for letting us know. One thing I want to add as color... No, sorry, that was it. Yeah, so it doesn't work, and Rodrigo also is unable to like even build it locally. And actually, I'm gonna... does anyone know if we have any meta employees who still work on multiply Torch Deploy?
Yes.
No. As for instance, we have people.
Shaheen or somebody.
Kristen does not work anymore.
Shaheen can only answer questions. He's not working on it anymore.
Yeah. I don't think we have anyone working on it. Sorry. Yes, we have a POC of like. I went through that loop of like being bounced to 5 different people until meeting a leaf. That was, yes, I can answer questions. But
okay, so Albin, tell us about the Pybind 11 upgrade problem.
Well, okay, this one is actually going to be pretty fast. We tried to upgrade Pybind. We have 2 issues. The main one being that ascend build for multiply just don't pass anymore. Bunch of issues with errors not being catched, and then some other ascend issues that I don't remember because we tried that a month ago. We tried to do an upgrade on the multiply side, and the PR is blocked because I don't know, there's a whole bunch of failures on their end, and yeah, no one can really help us get that through.
Okay, so I'm going to propose that we disable multiply CI on PyTorch main repo and give up on it. Discuss.
I've been trying to get this to work for the past month, and every time I find out by a meta employee a week later that hey, some random stuff failed internally, so we just might get even more of those if we disable it on CI.
So multiply is like our internal like deployment story for PyTorch, right? Or is it not?
No.
there are still there are still models being served with it.
Are we?
Yeah, but to
turning off of
be
it?
clear, like we're not running, Rodrigo, you're not running into OSS CI failures that are catching you trouble. That you're running into like green OSS CIs that then get reverted because of internal tests, right?
Well, I mean, if anything, I made some progress, and now I can hit the issue on CI. So
Okay, that's good.
my signal now happens, a week earlier.
Okay, so then the answer to the question, which is can we just turn off the CI on multiply and stop using it, is no, because we have people actually using multiply. Okay, so then my second question is, what do we do? Like,
Can we disable this feature on multiply for Rodrigo's problem?
Yes. So in particular, Verdugo, you could only import this module if you don't have multipy enabled. This was in fact the state of affairs for quite some time before I fixed Python op registration. So previously Python op registration just didn't work at all on multipy, and I fixed that, and then we changed it to loading things by default.
So that was the original fix that we had. We have that, but for some reason that is not reliable. We are checking if we're running under multiply, and with what I believe to be the way to do it by just checking the binary you were running under, and that is no longer the case to be working. Doesn't seem to be working anymore.
Okay, but that sounds fixable, right? Because like we are literally compiling different code in the PyTorch Python library if you're in the multipy. That's why you have to rebuild PyTorch from source when you're doing multipy. So that it could be just as simple as like exposing something more directly than just checking what the name of the interpreter is. So one consequence of this is that distributed PyTorch 2 would not work inside multipy. So back when we actually had people working on multipy, the reason why I fixed Python op registration was it was like, well, it would be good if we could run PyTorch 2 in multipy, which, seemed like a reasonable thing to want to do. So, I eventually spent I think it took a week to fix it. Any more comments? Objections?
Our internal PT2 deployment does use multiply.
Okay. I don't know who said that, but
What does that mean?
David, can you clarify what it means?
Yeah, we're using Torch deploy for training in the internal use cases that are using PT2.
Wait, we are? I
What-
thought we were
what-
only
which
using
use cases?
package.
Which use cases? Ads.
Well, is that true? I thought we were just using Torch package.
Oh, that's probably true, actually.
I don't know. I feel I don't know how much we're supposed to talk about internal use cases here, but there are some internal use cases. They are on the wane. I think, like, in the long run, we should probably try to just decommission it entirely so we don't have to keep supporting it with stuff like this.
okay, but this is just like Torch script all over again, right? Which is that the answer is unless you actually allocate resources to decommissioning it, it will.
It's
not
easier than
actually-
TorchScript because we still do not really have a replacement for what TorchScript does, but we do have a replacement for what Torch Deploy does, which is TorchScript.
But that's not actually true.
Oh,
Like
but-
if I want to
but
run
also-
PD2 multi-threaded, I cannot use Torch script.
Oh yeah, but nobody does that right now, so we have the benefit of nobody does that right
Well,
now.
but that implies we have to do this now before someone gets the smart idea. Oh, I can do a multi-threaded inference solution with PD2 by using torch deploy. And if they are unlucky enough to be confident enough to get it to work, then whoops.
Yeah, I don't think that that's that high risk because it is hard to make that work, but I do agree that it would be better to do it now than later.
Sorry, does do it now mean make an error message that we won't make this work, or does do it now mean make it work?
This is making it not work and migrating everyone off it.
Well, but I thought nobody uses it in PT2. What am I missing?
Right. So if no one uses it in PT2, then we can just make it error when you try to use PT2.
Okay.
So that sounds easy enough to do. Okay, so this does not help Albin's PyBind 11 upgrade problem. Alvin, do you have enough rope now or no?
I think we can take another stab at it later. So it will become a more significant problem once people start to use 3.11, because they are going to get thousands of warnings that they cannot silence.
Well, that sounds bad. Okay. Okay, so the resolution here is Rodrigo, because you're going to do this for distributed, can you, once you figure out how to reliably detect multipy, which I can help you with that, can you disable it for distributed and also distribute it like in torch compile or something? Like replace torch compile with a torch compile does not exist stub or something when you're in multipy.
Sure, I can take a look at that.
Okay, sounds good. So Rodrigo to turn off PD2 support in multipy, and that will also unblock distributed reg. And then Albin to try again harder to get multipy working with new PyBind 11. Sorry, Alvin. All right.
No, that's fine. That's fine.
All right, I'm moving on in that case if there aren't any other comments. Okay, let's do the possibly very long discussion first. So Will, optimizer API changes. Do you have a doc to present or no?
No,
Okay,
I know,
I'll
and
say it as you go.
I don't have API. I don't have anything to propose either. So what I plan to do is, I'm just gonna share what I'm trying to do in the train step compiler for optimizers, and ask a couple questions. And I think I also want to say I don't want to bike shed the. Basically, this is a POC right now. We have a full end-to-end thing that can compile a train step, including dot backwards and an optimizer with Dynamo. And it exists as a Dynamo backend today, which is maybe or maybe not the right way for it to exist later. So I don't want to bike shed that now. And I'm just going to scroll through the code and give a 3-minute overview of how it works.
All
And
right,
then
let me
I want to
stop
talk
sharing
about
that
optimizer.
case.
Yep. All right, so can folks see this? Make it a little bigger. Train step compiler. So most of the changes are in this part of the code. There's a couple of changes in Dynamo to allow it to put dot backwards calls into the graph and to put optimizer dot step calls into the graph, but those are pretty small changes in Dynamo, and they basically amount to Dynamo no longer graph breaks on these things and actually just sticks new calls into an FX graph. And later, Dynamo also needs to do safety checks, so that's also not covered yet. So there's a couple of constraints that if you're using this API, you'll have to meet these constraints. So like the input to this thing is a module that has fine-grained tracing of the forward of the module, just like it used to, plus very coarse-grained single call function or call method for like dot backwards and call method for dot step. I also also had Dynamo tag metadata for optimizers. So there's a module, graph module.meta contains this optimizers dict, which will have one optimizer for every optimizer Dynamo found. And that helps me so I can not have to search through the graph and look for them, and I can just like initialize the optimizers. So the rough plan here is to first initialize the optimizers, which I do by doing a warm-up call of this functional call. And then I later retrace the same functional call after the optimizer is warmed up. And then step 3 is to retrace that again with functionalization on in inference mode, and then just return a wrapper for that does the kind of reverse of parameterizing. It just takes the user args and puts them back into the call. So that's the high level picture. And the main issues that I'm facing are around how to initialize the optimizer cleanly. The current way it works is during the first warm-up call for the optimizer, I'm running it right here. No, sorry, right here. I'm running the functional call directly with fake inputs. And what this is supposed to do is cause the optimizer to create a bunch of fake tensors that represent its states. And the two problems that happen are that sometimes the optimizer actually creates real tensors, like singleton tensors, which aren't part of the fake tracing. And so for those, I end up zeroing them later. And for the ones that it does actually create as fake tensors, I actually have to replace those with zeros. And so that's bad. Ed?
Yeah, I have a quick question, which is how come you are in a fake tensor mode? Yeah, so my question is, when you warm up the optimizer, do you have a fake tensor mode enabled at that point?
No, I have a fake tensor mode, but I didn't enable it. So I just run the functional call with fake params.
Okay, we can move on, but I'm just pattern matching on whenever you have a situation that says, oops, I'm creating real tensors when I didn't mean to, the pattern matched solution to that is, oh, well, you should enable your fake tensor mode so that they become fake.
That's true. That probably would solve this problem. But it doesn't really solve it because I still don't capture the initialization of the optimizer, which is really what
there's some stuff about initialization, which makes sense. By the way, deferred initialization is also... Do we have any other relevant folks here? Shen maybe can tell us what's going on with deferred init. But let me first go to Dark Ritual. NYC?
Yeah, my question was about to be... did you discuss with Lazos that did the optimizer integration in Dynamo?
Briefly. Why?
Because we did separate out the initialization functions into a separate piece so that Dynamo can specialize on them already. So you could just call that.
That's a good point. Maybe I can have Dynamo actually initialize the optimizer for me, and then I can just assume that the optimizer is already initialized when I get here.
No, well, or if you need to initialize it here, just call these specific functions we have for it. They're not public, but Dynamo already relies on them existing, so it's not like you are less general than Dynamo.
Okay, so the underscore init group whatever thing, that's actually considered like an API in optimizers, and I can rely on it existing?
No, but it is assumed to exist by Dynamo. So
okay, so to my question, the answer is
it's not an optimizer
yes.
API, but it is a Dynamo assumption.
All right. Well, we can build on that. That might help.
Okay, well,
I mean, the other direction, yeah. So the other direction was to initialize the optimizer with real tensors, and then convert those all to fake, and then trace. And the advantage there is that I actually capture the init values, but I have to actually allocate memory during tracing, which could be a problem for large models. And I also have to separate out the init from the main part of the optimizer. Although I can do that now with Albin's trick. So maybe that's another route I could consider. So what do people think? Like, should we do real init here, or should we find some way to extract a trace of the initialization and then run it again with real tensors later somehow?
Why don't you ask the user to do that?
To initialize, basically tell the user they have to warm up before they can run this thing once.
Yeah, they have to warm up their module and optimizers. Because otherwise you're gonna hit the exact same frame with lazy modules. And then you're gonna have to do horrible shenanigans and then decide what to do and not to do.
So lazy modules doesn't have quite the same problem because their lazy init code doesn't really mutate anything like optimizers do. Optimizer init does the first init, and then it also runs the step which mutates the thing that you initted. But lazy modules, the way Dynamo handles it, is just runs the init before Dynamo starts. So it does have observable side effects, but it's basically correct because if you ran eager, the mutation would have happened. If you ran Dynamo, the mutation happens. In both cases, it's the same.
Why can't you do the same here?
Because if you run the init in the compile, you are doing a step. And the step is, so if we could actually run it once during, we could run it at extra time during compile, and then we'd have 2 steps. Then we'd have to like make the user run 2 steps to match it in eager, or we just tell them they have to run. Telling them they have to run it once before compile would solve this, to be clear. But I didn't want to make that assumption.
Rodrigo?
Yeah, so in our particular case, the user cannot really run a step because for what Will is trying to help us on this compiler is that the user has will provide us a model that is initialized, that is essentially a single rank model, which cannot be really initialized because it doesn't fit in memory. So we first need to compile to figure out the distribution strategy to then be able to run the optimized initialization. So there's no way for the user to do that on our behalf because they cannot know what is the actual distributed placement that the compiler tensors will take.
Wan Chao?
Yeah, and to add on Rodrigo's point, the optimizer is kind of problematic in terms of initialization. Like if we let user to warm it up, optimizer usually take like 4x or 5x memory compared to the model parameter itself. For example, Adam, they're actually taking 4x memory, I remember. So in terms of a relatively large model, it starts like not feasible, I feel.
Shen?
Yeah, to go back to Will's question, do we need a fake or a real tensor here? I would assume you're going to have to do a fake tensor here due to the reasons that Wan Chao and Rodrigo just mentioned. And we need to do fake tensor here, get a graph, and then later do detensor and sparse expansion. And after that, we know how to shard stuff. And then that's the point we can do real multiplication of the tensors.
Albin?
Yeah, I would expect that you will have exactly the same problem for lazy module as well. Like, I feel like you are going to go back into the deferred init question, and I guess we don't want to dive into that and not do that.
No, surprise! This is now a deferred init discussion. Okay. Shen, I heard indirectly that is it Anjali was looking into deferred init? Do you have any updates there?
Anjali is looking to fake tensor. I don't have updates on that one. She's on PTO right now.
Okay.
So essentially, I think what we need might be some functionality similar to TalkThis fake tensor and defer unit. Basically, trace what's happening during initialization and replay that on the real shards. That might be one option. If like what can also be like discussed might be if say the compilation overhead is not that high, we can also afford like compile twice, like once for the first iteration and then recompile for the second one when the train step graph actually changes.
Albin,
yeah, so I think that the biggest
go ahead, Will.
The biggest issue I'm seeing is that we can't solve this cleanly for the disk compiler with this current end-to-end POC because it's not end-to-end enough. And I think we need to put in a placeholder for something that consumes the output of this compile step and represents this compiler, and then try to mock like when we actually want init to happen and whether we're allowed to have real tensors before that point. I think that would help me to then really be precise about what the requirements are.
Shan?
Yeah, can we do something like this? So I think these are two separate problems. One is can the Dynamo trace a 14-step graph, and the second is can this compiler expand that into a distributed version. For the first part, can we just get a graph with fake tensor and then maybe having the materialization like purely in Dynamo for now. Later when this compiler is ready, I think it might make more sense to just register Dynamo backend from distributed package and handling all the distributed related expansion later.
So the issue is, and the reason I did this way is Dynamo doesn't actually start with fake tensors for the model. Dynamo starts with real tensors for the model, and to make it kind of equivalent, the optimizer is also supposed to be real. So at the end of my train step compile right now, both the model parameters and the optimizer parameters are all real. Which is neither of these is going to work for disk compiler. To be clear, we have to solve another problem first.
So if user provide a module on meta device, will Dynamo be able to trace the step?
I don't think it works. I haven't tried, but that's probably the next thing to look into.
So I believe that the state here is that if you try to pass a fake tensor into Dynamo, as in you have a torch compiled model and then you run it with a fake tensor input, we will error in that case. However, meta may or may not work depending on whether or not Elias removed the you cannot make a fake tensor of a meta tensor check. So that used to be an error, but I do remember there were some PRs removing this. I actually want to riff on this. Were there any other comments from the room? I want to try synthesizing the discussion here. So I feel like the way we might be able to factor this problem is as people proposed. So one is that you guys want some sort of eager mode compatible fake initialization strategy, and there's two levels for this. One is where you like know how the tensors were initialized, and another is just you got rid of all that information, but you'll play like a Michael Swo style trick where you have got some extra metadata like attached to the parameters that just says how to initialize them. So like you're just gonna like do the initialization out of band some other way. Let's just talk about the simpler case for a moment. So for the simpler case, do you need fake tensors or meta tensors are good enough for the initial like setup of your big model before it goes to disk compiler?
I think as long as we have sufficient information to pass to D-tensor to the expansion, that should be sufficient.
I think to answer differently, we can get by with meta tensors as long as we know what device we want to land on, but it'll be a better UX if we can use fake tensors.
Okay.
Because then the user can say what their device is up front and we can just trace it.
Okay, so then, so let's just say you're able to fake tensor a PHY module and initialize it without allocating the parameters. And you can do the warm-up that Albin wanted you to do simply by just running the model in standard eager mode with fake tensors. And so now you're going to have a model and optimizers with fake tensors in them. And then, Will, you're going to pass it to Torch compile. Is that right?
Actually, I think I already lost you. If I do what Albin said and run a warm-up step with fake tensors, I actually need to be in fake tracing mode. I can't just be with fake the resulting parameters are not going to have values, and I need that. I need the actual initialization.
Okay, so it's just so to clarify, it's not just a problem of how the parameters were initialized when the NN module was created, but also how the optimizer state was initialized. in the warm-up
Right.
step?
Right, because I'm trying not to assume they're always 0. Like I want to make it so that the actual init code either gets run eagerly at a later time or is traced, and then the trace gets transformed by the disk compiler and then gets executed at a later time.
Michael, so are you still here? How is S-curve dealing with this?
I'm still here, but I wasn't listening. So
So the question is, for your export workflow, the way you're handling parameter initialization is you just have some extra metadata on the parameters. So now the question is, are you exporting optimizers? And then do you also have similar tags for how the optimizer state should be initialized?
We export optimizers, but we don't export the actual like optimizer graph. It's just like a option, like you pick off a list and then you initialize it with the metadata provided.
Okay, so basically the optimizer is it's not actually a Torch optimizer.
Yeah, it's not actually, it's just a black box.
Okay, checking with distributed now, is that okay or is that bad?
So sorry, one more question from Michael. In that case, do you guarantee mathematical equivalence for eager?
No.
And
because there isn't even a eager implementation, right?
Well, it's the Apex. We just call it Apex kernel, so it's not like super complicated or anything.
And do you need a black box like Apex kernel for every different optimizer?
Yes.
Okay, then I think in that case we do prefer to have a graph instead of one black box.
Okay, so then let's do this on hard mode. So hard mode, so I was trying to simplify by not having to deal with the deferred initialization problem. But let's say we have to deal with a deferred initialization problem. Okay, so hard mode is not only do we need to fakeify everything, but we need to keep track of the initializations. But now Albin's warm-up idea is a little tricky because with warm-up, you're like running an actual iteration. But it's like you don't actually want the like results of having run that right. You want the initialization before you ran the warm up, because you don't actually want the like optimizer state updates from the first step, right? Like you're going to do the actual training, and that's when you actually want to apply those first steps.
Yeah. So this is what got me to the point of suggesting to propose an optimizer API change. And to be clear, I think the API change I might propose would have been already the change that Michael Lazarus put in, which is maybe not like a quote API change, but a secret API. But if we can tell people that they can call _init optimizer and we can trace that in a kind of blessed way, I think that might be what we want.
Albin.
Yeah, I think I would definitely agree with Michael's observation that optimizer initialization is very different from module initialization. In the sense, there is no randomness involved or no problem of determinism or equivalence. You can run it from wherever with whatever, and as long as you run it once, you're good. So we don't need to pre-initialize that state on the host so that we can then split it up. We could definitely initialize that state directly on the device after the sharding and everything happened. And it will do exactly the same thing because all these buffers are deterministically initialized given the original parameter state. So maybe we can just forget that question. If the problem is really just about optimizer, maybe that's another way to look at it, is to say our optimizer initialization is, I don't know what's the right description of it. You can run it in a distributed manner and it will give you the same results. So contrary to module initialization.
But one of the things you were worried about was what was going to happen when people had lazy modules. And lazy modules are in the parameter initialization regime.
Yes, but that does not apply. Yes, I definitely agree. Lazy module is still a problem, and like module initialization is still a problem. But I feel like module initialization is a problem in general in that sense. If you're saying, I cannot hold all the parameters on a single machine ever, I need to delay my initialization until after I've done the sharding. Yes, that is a problem, and if you have module initialization on top of that, but I feel like you need a distributed specific solution to that problem.
Okay, so synthesizing the proposals on the table right now. So the way we're going to do this is very bespoke, and it's going to depend on the particular problem we're solving. So for parameter initialization and lazy modules, what you will have to do is you will have to warm up your model by running the forwards. I guess forwards is good enough. You don't even need to run backwards. And you're going to run the forwards with lazy tensors, not lazy tensors, fake tensors. Fake tensors? Let's say they're fake tensors. So full-on fake tensors, right? And so the user is going to be expected to do that to prepare their model for Torch compile, so that you never are allocating parameters in the actual Torch compile trace. However, optimizers, we don't expect to be warmed up. Instead, we're just going to assume that there is a separate method, the init group, which you can use to initialize the optimizers. And then by some strange Rube Goldbergian series of events, you end up with a model where you have a bunch of fake parameters, and you have a deferred initialization context, which tells you how to go ahead and to create those parameters. Deferred initialization being some other box that you need to figure out. But that's not Torch compile. That's just whatever your deferred init API is. And you send that to Torch compile. You also send the optimizers to Torch compile, and Torch compile knows to use init group to get out what the initializations of the optimizers should be, and essentially mumble, mumble, mumble. We think you have enough information to do everything you need to do at this point. Will, do you agree?
I think so. I think so. I'll play with it some more.
I'm not sure why does, so going back to the very specific problem of optimizers in this new world, why do we need the Torch compile to do anything specific?
I don't think we do, actually. I think that the backend for train step can actually just find the init group thing itself.
I mean, it's just going to be whatever is doing the sharding and then getting everything set up on all the nodes before you're running, right?
Yeah.
If that's Torch compile, which I guess it kind of will be, right? Because the model for distributed compilers, you started with a single node model, and now it's going to be multi-node. So it's not really Torch compile, but there is a bigger system that includes Torch compile that is going to be responsible for all of this.
I think what ultimately happens is then we have to make it so the train step compiler can output a model with fake parameters first, and then it'll be okay to also output fake optimizer states. So we'll have to run the optimizer init during tracing so that we can properly trace the optimizer, but then we'll just have to tell this compiler to run init group again and override the first one, convert everything from fake to real using init group. I think that's what we have to do, because we do need to initialize fake states for the optimizer before we do the trace, so that we're tracing the optimizer updates to the
Otherwise,
parameters.
you don't even have a tensor in the optimizer at all. Yes. Albin?
No.
I think we can move on. I got a lot from
You want to
this.
move on? Okay.
Does anybody else want to last things? All right.
Okay, let's move on. Okay, going through the list, Peng wanted to hear about exportdb. So, Zhengshu, are you still here?
Yeah, I'm still here.
All right,
Can you
tell us
hear
about
me?
exportdb.
Okay, yeah. So, so what is exportdb? So basically, the problem we have supporting export use cases is we have multiple different group of end user who have questions on what PyTorch program can be exported or not, and we have to repeatedly tell them, okay, for this specific type of thing, you can is supported, but that other kind of thing is not supported. So over the time, we think it might be more scalable to have a better way to communicate all the common patterns and caveats for the Torch export API, what works and what not. And we are trying to in general, I agree. I think it's better to have like less caveats, and it's like less there's like less surprising moments when users are using export. But like right now, that's not the current status. So we're trying to put together a list of like common examples which user can look at and frequently ask about into like a centralized database, and generate documentation based on top of that, and present it to users. So user can like search or just like look at all the examples there. It's not meant to be replacing the intended documentation we are trying to write, but as a supplement to what we currently provide as document. So that's the basic idea. Is it like, yeah? Does anyone have question? Yeah.
Yeah, so the question is it mostly negative examples, things that didn't work, or also positive examples?
So the goal is to have both a positive and negative example, like as long as it helps users.
Okay.
Yeah.
I have a quick question, which is, can you screen share what's in the exportdb today? Just like walk us through a few examples.
Yeah. Yeah. So currently we just have an experimental internal page on like some common example, and currently we just put like a landing page on everything we have in the for example, and we also group examples by tags. These tags are not final, and they represent like general, like broad sense, like what's the common topics out there. For example, the control flow or dynamic shape. We can take a look at a specific example for dynamic shape. I just chose this randomly, and in this case, we have like a dynamic shaped model which has like a control flow statement in there, and as you can see, like we print the dumped exported graph also, and it's specialized on the first branch, and there should be a guard also generated based on this specialized branch. We haven't printed guard right now, but I think it will be also helpful to user to demonstrate like what's exported. That's basically one example, because people tend to ask a lot of questions around like dynamic shape plus control flow. Another thing is so like very specific example where we have a enum constant value, and the user use it in their model, and it doesn't work until we discover this is a real usage and we support it, and user actually asks like, okay, do you support this? And we just put like a special example of specialized enum value and model attribute here, and you can also see the generated graph here. So yeah, I can go with other example, but I saw Peng had a question. Yeah.
I would imagine the typical case, I have an export error or a graph break. How do I get from the error to this the relevant examples in?
Yeah, that's a great question, because I think currently I forgot whether it's Awake or Guang mentioned that we can actually, let's say, suppose this database is externally accessible, then we, in the error message, we can just demonstrate user like how to rewrite one thing to another thing, maybe unsupported thing to a supported thing with like permanent links. So that's one idea we can do, but we haven't do that now.
I'm going to defer to Elias first. Elias?
I know both Mark Serafin and Voz were talking about getting Dynamo hooked up in Godbolt, and it'd be cool to use Godbolt here instead of like static generated output, because like it would evolve as changes would made, and it would also maybe be more interactive and potentially like show guards or other things like that.
Yeah, that's a great idea. I think we can even generate links to Bento or like a collab so that user can even like, yeah, so the basic idea is after we have this sort of set of common example, user can do whatever they want and they can like play in a more interactive thing. But right now we are focused on like just populating like the most representative examples. I think that's the more important part for now.
Okay, I have another question, which is so if I like imagine the equivalent of this, but not export oriented, just regular PD2 oriented. It sounds to me like this is basically this is the stuff that causes graph breaks, and how to rewrite your code not to use graph breaks. Would you agree with that?
Yeah, I think like in my mind, it roughly is similar to what we described, I think.
Okay, so then do we really want to call this exportdb? Like, it sounds like what we're doing here is we're just more sort of elucidating like what Dynamo can support versus not.
Yeah, I think it's similar, but I'm not sure like that's entirely related to Dynamo because some parts are still related to other core parts, and it just represents like how we like the end user of export might ask because like we actually ask user to rewrite their model when some exported program doesn't work in the current status. So user might have question on like what they could do in this case. In PD2 in general, I think we can always fall back when we have graph break. So user just might like I'm completely like guessing, but I think user might not have those type of question if they can just fall back.
Sorry, Voz, I'm going to preempt you for a moment. So you showed us two supported examples. Can you show us a not supported example?
Yeah, sure. I think Dynamo support is pretty good these days, so I actually need to find which one is not supported.
Class method may be one.
Plus, which one? Sorry.
Example
Maybe
one,
top
class
example.
method.
Okay. It is supported.
Yeah, but the reason we added this was type of something was not supported.
Oh yeah, so I think this example 2. So we put a support level not supported here, and as we discussed with Yanbo, like this example is not supported when we call like type specific custom type object, and it calls a class method and is not currently supported.
Okay, I have a question for this, but Voz, go ahead.
Yeah, I think this is great. It would be cool if you separated it out by supported versus unsupported instead of just by like enumerated examples, because I think the story for supported is like recipes, and the story for unsupported is pitfalls / things you have to rewrite. Is that correct?
Yeah.
Cool. I'm also very curious in things that are not supported but are not graph breaks. I think to Ed's point, that's a one-to-one set.
Yeah, so my view of this is very early, and right now we're just populating with tags, but the actual like categorization of things will be very important in the future. So the supported, non-supported, or even like how these tags are organized hierarchically, we have to kind of make it easier for people to search and find things.
Well, I think the bigger point is that this is not really export specific. Like if I am a power user of PT2 and I want to remove graph breaks from perf, I might care about the same set of things.
All right, I'm going to jump in. So when I look at this example, I don't understand why this isn't supported. Like this just sounds like a Dynamo bug, and we should be able to support it.
Yeah.
Yeah, is anyone who was in discussion why it's not supported in this meeting, like Yanbo or?
So Yanbo did triaging and concluded that this was hard. And in this case, the workaround is pretty easy. So there is a living doc that is triaging these things.
I actually agree with Ed because I also feel surprised, but I guess that's the point of documented explicitly here. Otherwise, it's like as a user, I would rather somebody tell me, okay, this specific thing is not supported than like we don't know.
So I could believe that we have cut too many corners in Dynamo and making this supported is hard. But so there's like, to me, there's a difference. And maybe you've got one of these here as well, which is something that is sort of hard for incidental reasons. Like this might be hard because we're not accurately tracking the types of user-defined objects, and then we don't know which functions to inline into when you like call onto them, right? And so just more accurate modeling in Dynamo would solve it. Whereas, like, let's say that you have an if statement on a dynamic size input, like that was one of the first examples you showed us. Actually, that example, you should have a like supported and not supported like version of it, right? Because the not supported version is when the input dimension is dynamic. And that is like fundamentally like just like from a research perspective difficult to support transparently.
Yeah, I think I agree with that because I do think it's much hard to populate non-supported cases because they could be incidental or like fundamental. For supported cases, we just have a general sense of what can be what's the common like thing is supported there. So that's why we are trying to work on like supported case more because if you look at a database here, we only have like a handful of non-supported case, and maybe they'll be supported someday. And I think and for dynamic shape, maybe I think it's better to co-locate supported and non-supported case on the same like user accessible material. Like that's Peng?
Yeah, also a general question, how do you systematically track supported and non-supported? Because right now I see this is based on the model enablement work. A lot of it is from the Reality Lab models, right? But there are all kinds of other models. How do you make this database relatively complete or representative?
Yeah, so that's a good question. I hope I can do that because if I can do that, it would be awesome. But currently our goal is not to make this complete, to be honest, because it will be a very hard thing to do. I think the point of having this database is very easy to add something simple here and just for keep something on record. For completeness, I think maybe according to our previous discussion, it's better handled by more high level document like on like what in general can be supported or not. So that's what I'm currently thinking.
I just want to push back on the idea that like the organization of these isn't as important because like there are a lot of things that Dynamo supports. So like when you have 200 examples of stuff that is supported that's sort of just in an undifferentiated slurry, like that's a problem, right? Like you want it to be structured like kind of like the language reference for Python or something like that.
Yeah, I think like to maintain a independent and minimal but also representative like thing is what I want, but it will take some effort to do that, and yeah, I agree. I admit that. So
Yeah, just one last thought. I wonder if we should prioritize unsupported cases because that's what users need help with to mitigate to project models.
yeah, I feel like whether we can prioritize that depends on whether I can get user to actually work with us and say like I want to know what's unsupported, because I feel like sometimes I feel I do some try and error in Dynamo or export, and that's not what the user actually thinking about. And that's why we are working with Guang. Like that's one instance where I actually want to learn about more like what they are thinking about. What when something is not supported, they want to know explicitly. Yeah.
All right, we are at time. Thank you for everyone who presented. See you all next week.
Thank you.